Hello and welcome to the topic 2.2 worksheet. Here we go. We'll run through some of these problems. Okay, name the property of equality that the statement illustrates. Here we go. So if and a then are classic. If and a then, if x equals y, then 3x equals 3y. So what happened? What do? We started with this, and then we multiplied by 3 on this side. And if you do it on that side, then you have to do it on that side. So this is all good. If we start with this, then by the multiplication property, then 3x is equal to 3y as well. So do it to one side, you got to do it to the other side. If am equals mb, then am plus 5 equals mb plus 5. So we started with this. We added 5 to this side, so we have to add 5 to that side. That's the addition property of equality. Addition property, so just do add prop like that. X equals x. This is just itself. This is the reflexive property. This is the last one I'll do with you, and then maybe we'll go over some. Let's skip down here to 32. See if you can figure out the rest. Look, there's another reflexive property one right there. You see it? It's just equal to itself. BC equals XY, XY equals 8, so therefore BC equals 8. Now we can write these together. BC equals XY, XY equals 8. We're going from BC to 8. That's the transitive property. All right, next set. All right, do those and see what you can come up with. Next set, number 33, it says use the property to complete the statement. All right, this time the substitution property. So we're going to replace AB equals 20, then AB plus CD. So I'm going to rewrite AB plus CD, but here's what I'm going to do. I'm going to erase the AB, and what can I write in its place? What can I write in the place of AB? Well, AB equals 20. So I can put a 20 in there, and it's all good, because this is now equivalent to this, because AB was just replaced with 20, because they're equal. That's the substitution property. The symmetric property, that is if A equals B, then B equals A. That's the symmetric property. So here we go. If 1 equals 2, then the measure of angle 2 is equal to the measure of angle 1. You just flip them around like that. That's the symmetric property. It's kind of like the converse, isn't it? It's kind of flipped. All right. Let's do the transitive property down here, number 39. If 1 equals 2 and then 2 equals 3, then that means the measure of angle 1 is equal to the measure of angle 3. It's like you cut out the middleman. We can go straight from 1 to 3. Reflexive property is just always going to be itself. ABC is equal to ABC. Okay, next. Write the property that justifies. So as I go, here we go. We're going to start with this. Now, what happened from here to here? 7x disappeared, right? Where'd it go? What do we do to the 7x? It looks like we subtracted it. So this would be your algebra. If we were in algebra class, you would say that and that. Okay, but in geometry, you don't have to do that algebra part. We just want you to show us what the next step is and why it is the next step. So this makes this true, and why? What happened? We used the subtraction property. And then from there, what happened? What happened from here to here? This 12 got added. We added 12 here, we added 12 here. That turned into a 20. We did the addition property. And then what happened from here to here? We divided by 4, we divided by 4, we use the division property. All right, see what you can come up with for number 4. Okay, next. Just more general thinking here. In the diagram, the measure of ACB is 25 degrees there. label that. And CE bisects DCF, I'm gonna label that. That's a bisector, yeah, I labeled that. Explain how to find the measure of DC. So how would we find the measure of that? All right. Could you find the measure of it, first of all? And you'd have to kind of know your stuff to find it. All right, so I'll show you, and you got to write a little sentence or two. Basically, first, you could say that has to be a right angle. If this is a right angle, then that's a right angle. And if this is a right angle, they're complementary. And if they're complementary, then that makes this have to be 65. Because what is 65 plus 25? Would be 90. Okay. And then we got these vertical angles here. So if that's 65, that's the same as that. I'll put 3. So that makes that 65. And then we got 180 altogether here. You got a nice line. So anytime you have a line or a straight angle like that, you got 180 degrees. So now that makes this angle have to add up to 180 with the 65 degree. So that makes this piece right here have to be 115 to add up to 180. And now take 115 and cut it in half to find these two right here. So what would that be? It's 115 got divided by 2. $57.5. Here you go. 57.5 was the answer. So could you write a sentence about that? Could you say all that in sentences? First, we have to use a 90-degree angle and complementary angles to find 65. Then we have to use vertical angles to find that this is 65. You know, and I guess we could use this. And then we have to use like a straight angle to make 180 degrees. When you add all these together, you get straight angle. And then we have to bisect this, so 180 it makes that 115, and then you got to bisect it, so cut it in half, and that's what you end up getting. You can write that in a sentence. On to the back. Do a couple of these. It says write a 2-column proof. So let's do it here. Statements and reasons. Those are your 2 columns. All right, the first statement is always a given, pretty much 100% of the time. Some type of given. You have to start somewhere. And apparently this is true. Okay? So apparently that's true. Now what do we do? Well, if I was solving this in algebra class, I would do a -4 from both sides. Okay, but this is an algebra class. We're just going to show the next step. We're just going to write. What would that be? What would happen if I subtracted 4? That would give me 6x equals 12. I use the subtraction property. I subtracted 4 from both sides. And then if this is algebra, I would divide by 6 on both sides. But we don't show that in geometry. You don't need to show that. That's kind of, we're too good for that now. So we're just going to divide the 6, and you're going to end up with x equals 2 using the division property. Let's go to the next one. Get your statements, get your reasons. You can just put S and R if you want. So start with your given. Okay, now what? It's the next step in our algebra. This is maybe debatable, but this is what my next step would be like. What did I do? And you could do this differently. You could have added the 1/3 x over. That would have been fine. But I'm going to get rid of my fraction because I don't like fractions. So what just happened? I multiplied 3 on this side, and I multiplied 3 on this side of the equation. So I used the multiplication property. Multiplication property. Okay, next. 3 times 3x is 9x. Technically what I'm doing right now is I'm substituting this right here with a 9x because they're equal. And over here, I'm gonna do the distributive property. So that'd be 30. And then 1/3 times 3 is just x. So there we have it. Distributive property. And technically there was a substitution as well. I'll just put that in parentheses. So technically I substituted this with this because they're equivalent. And then I distributed my 3. All right, now I'm going to add the x over. Like that. So this is now the, I did the addition property. And then lastly, I'm going to divide the 10. And this is the division property. All right, let's try this last one. You're going to do the third one on your own and see how you did. So statements, reasons, and here we go. By the way, notice that I'm always getting the final answer is exactly what I'm trying to prove. Final answer is what you're trying to prove. Now plug it in, you're just working it out. 2x plus 11 over 5 plus 7 equals 5x. All right, so you always start like that when you're doing these. Then from there, here's what I would do, technically, if it was me doing it. That's nothing, I didn't do anything. I'm going to multiply both sides of the equation by 5. That's what I'm gonna do. Now there's lots of options, you could do this many times differently. You could take the 7 and get rid of it. So that's called the multiplication property. Then what I'm going to do is I'm going to distribute. I'm going to take this whole thing and multiply it by 5, and I'm going to take this whole thing and multiply it by 5. Now, this is where a lot of students go wrong. When I take this whole thing here and distribute my 5, all that does is it takes this 5 away. So that kind of cancels that out. So now I'm left here. And then don't forget to distribute the 5. And then on this side, we got 25x. Technically, I was doing a substitution. So there I just did the distributive property, is what I did. Then I'm going to do 2x. What can I substitute 11 plus 35 with? Technically, I'm substituting. 11 plus 35 is 46. I'm going to call that a substitution property. I substituted this value for this value. Then I'll take the 2x and I'll subtract it over. Okay. I use the subtraction property. Notice that I go out. You got to go out at least 4 letters or else you won't be able to distinguish subtraction from substitution. And I'm going to divide. So divide the 23. 46 divided by 23 is 2. Ooh, interesting. And then lastly, I was trying to prove that x equals 2. I proved that 2 equals x. So now I just have to flip it around, and that's the symmetric property. Symmetric property. And we got reflexive, symmetric, transitive. That's the symmetric property when you just flip it around. Okay, do your best on this one. You know what the answer is. Work it out. Start it like this. Statements, reasons. Start like that. End like that. Start like that, end like that. Somewhere you're gonna end up like that. And that's all I have to say about that.